Hey, let's jump into key skill 8. In key skill 8, we're going to be looking at intersecting chord and diameters. We covered the proof in the previous video. So let's sketch our circle. The circle's equation is x minus 1 squared plus y plus 2 squared equals 9. So the center must be at 1 minus 2 and radius 3. So that's our circle. If you're finding it a bit hard to go straight from the equation to the sketch, then make sure you check out the earlier key skills, key skill 1 and 2. Now we're told that A and B are points on the circumference. So we've got 1, 1, which would be right about here. That would be point A. And B was point minus 2, minus 2. So that would be here. And A to B is a chord. So the chord goes like this. Now the difference between a chord and a diameter, a chord and a radius, is it doesn't pass through the center. You can see that. This is our center over here and it definitely hasn't gone through. Now we're told that the line L is perpendicular to the chord and passes through the point C. So the point C is the center. So the line L is going like this. It's passing through the center. I actually draw it in red because it is a radius. It's passing through the center. It's intersecting the chord at a 90-degree angle and it's coming out the other side. And we've been asked to find the point of intersection, so we need to know this point here. Now, this is where the theorem comes in handy. We know that if it's a 90-degree angle between the chord and the radius, or the chord and the diameter if you're going the full way across, that A to B has been bisected. A to B has been cut in half. We learned that in the proof, right? In this case, we know that there's a 90-degree angle because they've used the word perpendicular. Remember, perpendicular lines meet at 90 degrees. So we know that that's 90, and we know that it's a radius intersecting a chord. So that must happen in the middle because we know that this length has to equal to that length. So to find the point of intersection, it's really easy. All we're going to do is use the midpoint formula. If you don't remember the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And we're going to use our endpoints a11 and b minus 2 minus 2 as our x1, y1, x2, y2. So let's sub them in. 1 minus 2 divided by 2. And for the y's, 1 minus 2 divided by 2. 1 minus 2 is minus 1, so it'll be minus a half, comma, minus a half. And if we look at our diagram for where the point is, that definitely makes sense. And that's that question done. The question is really simple and completely unlocked by the fact that you know that the 90-degree angle implies that B to the point and the point to B, they're equidistant, they're the same distance, so this point here needs to be perfectly in the middle. Let's have a look at the second question. We've been told in the second question that the circle has a radius of 10 and a chord AB of length 12. So let's get a rough diagram going. We can't plot this on a coordinate axis because we haven't been given specific points, but we can still draw a diagram. So we can imagine, for example, that the points A and B on the chord are here. So here's A, here's B. And we know that that length is 12. Can imagine the center's around here. And we've been told that the line L passes through the center and the midpoint. Okay, so the line L passes through the center, so it has to be a radius, and it passes through the midpoint. Now, we know from what we've learned today, so that purple length is 12, and we know that the radius is 10. We know from what we've learned today that if it's in the middle where the radius and the chord intersect, that implies that there is a right angle here because it's been bisected. The chord AB has been cut in half by the radius, so there needs to be a 90-degree angle there. Now, we're asked to find the shortest distance from the midpoint of AB to the circumference. So what we're going to do here is form a right angled triangle so we can make use of our trigonometry. So if I put one here, for example, I know that this is the midpoint. So I know that this length here has to be 6 because half of 12 is 6. So that has to be 6. Now from the center to the point A, it has to be 10 because that's the radius, right? So that's 10. So what I can do is I can find x. Now if I can find x being the distance from the center to the midpoint of AB. Now, I know you're saying, well, that's not the distance we want. We want from the midpoint to the circumference, and I'll get to that in a second. So use Pythagoras' theorem here to find the length x, and x is from here to here. So here's the height because it's opposite the right angle. So we have 10 squared equals x squared plus 6 squared. 10 squared is 100, and 6 squared is 36. 100 take away 36 is going to be 64, is x squared, and the square root of 64 is equal to 8. So that distance there is 8. Now, the shortest distance is always the perpendicular distance. So if this whole line is radius, and that's 10, and this little bit here is 8, we can find this bit here by saying 10 take away 8 needs to be 2. And that's the distance they're talking about because they say the shortest distance to the circle. You could get from this point to the circumference here or here. There'd be different lengths, but they specified the shortest distance, so they want the perpendicular distance here. So calculate this little bit here by making use of this right angled triangle here, and then do the whole radius and subtract the 8. This is a rework of a previous exam question that I saw, and I thought it was really tricky. So let's have a go, guys. Oh, we can get a diagram going even though we're going to have the center here in terms of k. So the center has to be 4, k, and we've got 2 points which are 7, 6. So let's imagine that's there. And B is 0, 5. Okay, so we can imagine it's there. Now, we can say that from A to B, it's going to be, well, from A to B is a chord, right? Now, we've been told that we need to find the value of k. The method for this question is to find the equation of the line here. Now this would be a radius, and we would know that this would be a 90-degree angle here. So what we do is we use the 2 points that we do know to get the gradient, and that means that we can find the perpendicular gradient of this line. Now we can also find a point on the line by using the midpoint. Once we have those 2 pieces of key information, we have the gradient and we have a point on the line, we can find the line's equation. If we know the line's equation, we can substitute in 4 for x and k for y and solve for k. So let's try and get the equation of this line here. Let's start by getting the point on the line, which is going to be the midpoint. The midpoint is going to be 7 plus 0 divided by 2 and 6 plus 5 divided by 2. So 7 plus 0 is 7 divided by 2, so that's going to be 7 over 2. And this one's going to be 11 over 2. So now we've got a point on the line. Okay, we can pencil it in. 7 over 2 and 11 over 2. That's going to be that point right there. Now we also need the gradient, so we find the gradient from A to B by using y2 minus y1, so 6 minus 5, divided by x2 minus x1, 7 minus 0. 6 minus 5 is 1, and 7 minus 0 is 7. So the perpendicular gradient, the gradient perpendicular to AB, would be minus 7. Now we've got the two pieces of information we need to find the equation of the radius. So we'll do y minus 11 over 2 equals gradient x minus 7 over 2. You could go ahead and tidy this up if you wanted to, but I'm just going to straight away plug in because I know that my center is on this line. I know that the radius and the chord are intersecting at 90 degrees. So I'm going to go ahead straight away and plug in 4 for x and k for y. So that must mean k must be equal to minus 7 times 4 minus 7 over 2 plus 11 over 2. I'm going to type that all into my calculator at once. Wait. 4 minus 7 over 2 is obviously going to be 4 minus 3.5. So k must be equal to 2. I'm just going to briefly recap from the method. We know that if we've got the chord here, the line that passes through the center, which we want to find out, goes also through the midpoint of AB because it's cut in half, and it's perpendicular because of the right angle. We use both of those pieces of information to get an equation for the radius. And then once we've got the equation for this specific radius that's passing through the middle of here and is perpendicular to it, we just plug in this for x, this for y, and solve for k. And that wraps up key skill 8. Key skill 9 is the last one. Congratulations for staying with me so far. You got one more to stick it out, and I will see you in the next one.